Hi, team. Two more questions to take a look at with your review, and I hope everything is going smoothly tonight. If not, bring me your questions tomorrow morning. We'll certainly have time before we start writing the test. Oh, here comes my son. So here's Kate. Kate is in her boat off the coast, so you'll certainly draw a picture of her boat. We'll put her boat here. And this coast runs straight north and south. Oh, okay. So I thought the coast was to the south of her. All right. Yes, and she notices that the that she is 8 kilometers from Haytown and 10 kilometers from Beeville. Okay, so if Haytown and Beeville run straight north and south, then they would be up here. Haytown. We'll put Haytown here. H. And over here, B for Beeville. A little bit further away. And that will create a triangle, of course. So here is the line between her and Haytown, 8 kilometers. And here is the line between her and Beeville, 10 kilometers.
That's it. No.
80 degrees in between.
Why you trying to be slow?
And we have been asked to find the distance between Haytown and Beeville. And for that, we don't need any other triangles. This
You
is
already have it on yours.
okay, one moment. Okay, let's carry on. So we've been asked to find this distance between Haytown and Beeville. That's just a two-dimensional cosine law problem. And oh, by the way, there's a helicopter over here, which we will call C for copter. Okay, and it's directly in between C, but it's 1,000 meters in the air. It's 1 kilometer. So, and it's directly in between. So we're told that's directly in between. So we're gonna be drawing a line from there to there, figuring out how long it is. That's actually, there's some doing to do for that. Okay, first let's find this side. Okay, so we know that, what do we know? We know that the length of this side, we'll call it HB. We'll call this a side, this is side B. Okay, I'm just going to draw side B over here. The copter is a copter. Don't get that confused. This is side B, and this is angle B. Okay, so here, B squared is equal to 8 squared plus 10 squared minus 2 times 8 times 10 times cosine 80. All right, so that's something that you can go ahead and plunge in your calculator. We're going to have 164, and this is going to give us minus 160 cos 80. And then that gives me something to punch. So I'm going to go ahead and do that. Sit tight, everyone. It's faster for me to just punch it than it is to pause the video for you. You can also fast forward these parts. All right, it's clear. 164 minus 160 times cosine of 80 equals 136. So this is b squared is 136. I'm often surprised by this. I'm like, wait, what the heck? Oh yeah, right, it's squared. So b squared equals 136.2, blah, blah, blah. I'm just going to keep it on my calculator. I take the square root of both sides to find b equals square root of the answer. Yeah, 12.7. So it's 12.7 kilometers between these two places, and that doesn't surprise me in the slightest. That looks pretty well like 13. So we'll keep it as 12.7 to the nearest tenth of a kilometer. So yeah, 12.72, so that's 12.7. So this boat is right in between them. All right, right in between them. And that's going to create some funky triangles. Okay, so let's take a look at those triangles. All right, so give me one moment. My son is right here. All right, team, I'm back. And one of the things I'm a little confused about with this question is with the median here. What this is it's a median. Okay, the copter is right in between these two places. So we can calculate this distance and we can calculate that distance. But if we want it to be really accurate, in terms of how far it is from the boat to here, we need to calculate that distance too. Now the problem is, once I put a median through there, it does not necessarily cut this angle in exactly half. That's only true for like isosceles triangles where these two sides are the same length. Okay. This also, I thought, well, can I sort of argue that that's 9? And no, you can't, because it could even be less than 8 and less than 10. It doesn't have to be right in the middle of these two lengths. So there's a lot of problems with this question here. It's certainly calculatable, but my instincts are to now find these points and find that point and find that point and use my knowledge of coordinate geometry. And that's not the topic in this unit. That's not what we're doing. Okay, so I did a bit of research online and I said, how do I calculate the length of a midpoint? And this is the formula that I found. That's certainly not something that we're doing in this class, is using this formula. Okay, you take 2 times one side, the square of one side, and then 2 times the square of the other side, and then subtract the square of the third side that has the median, then divide the whole thing by 4. Okay, and that will be the length of the median. Oh, you take the square root of it too. Okay, so there's a lot going on there that we're not doing. So this question is, I don't know if they set it up and didn't realize what they were doing when they set up this question, or if there's just something that I'm not seeing. But I don't know this question. Hold on one moment. So let's move on to the next question, is what I'm saying. All right, let's take a look here. Last question. We have 2 roads intersecting at 34 degrees. So here they go, pion, pion. And 2 cars leave the intersection on different roads. One goes 80 kilometers an hour for 2 hours, so he will travel 160 kilometers. This is actually the distance is given because they gave you speed and time. So you have to do some multiplication. This one goes at 100 kilometers an hour, so he's going to travel 200 kilometers. And after 2 hours, a traffic helicopter is hovering above and between the 2 cars. So the traffic helicopter is somewhere along this line. Okay, it's above and between them. We don't know where on that line. And he takes readings on both cars. The angle of depression to the slower car is 20 degrees. So let's zoom in. I've drawn this for you. And the straight line distance from the helicopter to that car is 100 kilometers. So if we go along this line, that line is 100 kilometers between the slower car and the helicopter going straight up and down. I also used cosine law to find the distance between those 2 cars to be 112 kilometers. So that's another thing that we know, okay, is that this side, this is 112 kilometers. And now we know that, and what else do we know? Yeah. We know the, oops, let me undo that. My goodness. Okay, so we know that this angle of depression is 20 degrees. That means that the car is looking up at 20 degrees to see this helicopter, because this is the line of the horizon and this is the line of the ground, and they're parallel. So if this is 20 degrees down, this will be 20 degrees up, because this is a straight line. So now we have a known side and a known angle. From that, we can calculate the height of the helicopter. And then that will be determine the height of the helicopter. Yeah. And we also want to calculate then the straight line distance from the helicopter to this car over here. To me, I'm going to calculate B first and then calculate A, because this is an unknown angle here, because I don't know the angle of depression looking at that car yet. So let's do B first and then we'll do A. Okay, let's go.
Well, Zara, let's go downstairs. Why? Why are those back here?
Okay, so let's go. All right, so this is a SOHCAHTOA problem. Once I have calculated this here, once I have my map anyway, my diagram, this is just SOHCAHTOA to find this height here. So what I will do is I will draw that triangle separately. The helicopter is at the top of the triangle, and the slow car, we'll call it S. Let's call this H for helicopter. And this is a right angle. This is 100 degrees. This is 20 degrees. So what relates this to this? Sine. Sine relates that to that. So I would say sine 20 degrees equals 100 divided by, call this the h, little h, height of the helicopter. A little bit of rearranging. I'm going to multiply by h, both sides.
Daddy, we're going downstairs to watch.
All right, Miles, you have fun watching your movie. So I multiply by h both sides and divide both sides by sine 20. So these will cancel. These will cancel. And I'm left with 100 divided by sine 20 is the height of this this helicopter. No, it's not. Okay, so I've mentioned that I don't work very well when I'm distracted, right? Right. Yeah, that'll be my excuse for now. Okay, for some reason, when I set this up, I did not remember. I used to secant or cosecant. Let's do this again. Okay. Some of you were yelling at your computer screen, and I appreciate it. I appreciate you. Sine 20 degrees is equal to. Notice I make a lot of mistakes, but I catch them. Okay, that's the lesson here. Is equal to h over 100. All right, it's opposite over hypotenuse. So SOH. What I had was cosecant. All right, now all that needs to be done here is multiply both sides by 100. And then I get my answer. 100 times sine 20 will give me the answer that I'm looking for. The height of that guy. So let's find it. 100 times sine 20. 34. So 34 kilometers in the air. So you have to ask, who made this problem? 34 kilometers in the air? No, it's not. It's not that high. But according to the math, it is. So what we say here is there's a problem with the math. Really, they should have a 2-degree angle of inclination. Then it might be 0.8 kilometers high. And I think even that's pretty high for a helicopter. A helicopter that's a kilometer in the air, I think, is pretty high. So anyway, maybe that's not true. Maybe I don't know the altitudes of helicopters, but I know it's not 34 kilometers. So now we can use that. Okay, we'll put that on your diagram. This is 34. And this is an unknown side. This is an unknown side, but we can find it. Okay, how would we find it? Well, we'll put this on here, 34. And now we can just use Pythagorean theorem. Call this D1 and this D2. Okay, and D1 plus D2 is 112 kilometers. And I'll show you how in a second I got that. I know that was done off camera. So here, let's go. So now to find D1, I would say 34 squared plus D1 squared equals 100 squared. So doing those on my calculator, so clear that. 34 squared is 1,156. Plus some value D1 squared is equal to 10,000. Okay. Subtract 1156 from both sides. Gives me D squared, D1 squared is equal to minus 1156. 8,844.
Daddy?
Yes, my dear?
My tummy is aching.
Oh dear. I wonder why that's happening.
I ate too much food.
Oh. Did you know? Well, you seem to be full of good pep. You seem to be happy. Okay. I'll give you a cuddle in just a second. I'm almost done here. You need to burp soon, eh? Okay, that was good. So now we're finding that this side is 94 kilometers.
Daddy.
Oh, do you feel much better now? Good. I'm glad that you burped. So now I can put that on here, 94, and that will tell me this distance. Once I have that distance, I can find the straight line distance. Because I don't have any angles over here except for this 90 degree. Just remember that. This could be any angle, that could be any angle, so long as these two add to 90. We don't know what they are yet. That would change the answer. So we have to go through distances. So 112 minus 94 would give me 18. Yes. So D2 is 18. Okay. So now if let's go back over here to this one here. D2, I got in trouble doing things in my head a while ago. So D2 is equal to 112 minus 94. Let's just do it on my calculator, right? 112, clear. 112 minus 94 equals 18. Okay, now that's 18. And now I can draw this triangle. Pion, pion, pion. 18, right angle here, 34. And we don't know the straight line distance, so we'll call that S for straight line distance. Okay. And now we would have 18 squared plus 34 squared equals S squared. 18 squared plus 34 squared equals 1,480. And then I take the square root of 1,480. It's 38. So S is equal to 38.5 kilometers. Okay, so now we found all the required information. So we've calculated the straight line distance to the nearest kilometer. So it'll be 38 point. Actually, it's just 38 because I rounded up to 5. So this would actually round down to 38 because it was 38.47. That rounds down to 38. But it rounds up to 38.5. You can't then round up again. All right. So anyway, so we've calculated the straight line distance of the faster car. The helicopter is actually much closer this way than it is that way. And we've determined the altitude of the helicopter to the nearest kilometer is 34. It's craziness. It's way too high. This is how we approach these questions. Oh, I told you I would show you how I found that, right? So that was cosine law. And that looks like this. We wanted this distance, right? And so we would say we had a triangle. It looks like this. 34 degrees. 200 here. 160 here. And we want this distance, call it W. All right? And now I set that up with cosine law because I have no opposite angle, opposite sides. W squared is equal to 200 squared minus 160 squared. Sorry, plus 160 squared minus 2 times 200 times 160 times cosine of 34. I'm always in the way. 34. Okay. And then when you work that out, it tells you that that's 112. All right. So that's your formula, and you just punch it. So it looks like this. If you're still with me here, wow, my goodness, I need to give you another secret code word. 40,000, 400,000, 40,000 plus 16. Jeez. Gosh. 16. So that's 25,600 minus 32. Miss the calculator I use at school. It's better than the one on my phone. Okay, multiply this by cos 34 equals. So that's so this gives me W squared is equal to 112. Sorry, 12. Oh my goodness. It's late. I need to get some sleep. You need to study. 12541. 0.6. Take the square root of that. Come on now. And it gives me 112. So thanks for sticking around. All right. So we now know W. 112 km. 112 kilometers between them. All right, everybody. So I very much look forward to seeing you tomorrow, helping you out where I can with this material. And I hope that your studying goes very well. Any questions that you have, be sure to bring them to me tomorrow before the test. Bye for now, everybody.